Welcome to Third Angle, where we're silently soaring on an electric-powered flight. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. H55 is a Swiss company dedicated to decarbonizing air transport using electric propulsion systems. Supported by PTC partner Ineo Solutions, they're at the forefront of developing certified electric systems for the aeronautics industry, including engines, energy storage, and battery management. H55 was founded in 2017 by the former senior leadership team of Solar Impulse, holders of the world record for the longest non-stop flight with a hybrid solar-electric powered aircraft. H55 systems promise to transform air travel and make it cleaner, quieter, and more affordable. Our producer, Giles Pitts, visited the H55 headquarters in Sion, Switzerland, and spoke to co-founder and chief sales and marketing officer, Gregory Blatt. Gregory takes us on a tour around their headquarters and tells us about their B-23 aircraft, a two-seater training aircraft powered by electric propulsion.
Welcome to H55. We are at our flight operations and integration facility. Here in Sion, we have three facilities. We have engineering offices. We have a production facility where we produce our battery modules. And here, where we are which is in the airport of Sion, which was formerly a military hangar. This is where we do our flight testing work, our assembly, and where we fly from, basically. So we're looking at the first prototype here. We started flying with this airplane in 2019. We just retired it right now. It's flown well over 100 hours and maybe more flight testing. It's still flyable, but we're always very safe and secure. So we use this for demos, for static display and things like that. This will not be the final product, the certification. There'll be we've built a second one, and then we'll be building a third and fourth one, which were the ones what we'll be presenting to certification authorities. Well, we're looking at a very sleek two-seater, 750 kilogram maximum takeoff weight. The certified product will be over 850, but this one is 750. Just two comfortable adults that can fly in this. Flies for an hour, has a reserve, has about 20 minutes of reserves as well, which is perfect for flight training circuits because typically they do circuits for flight training. They do circuits around the airport, so that allows them to do that part of the program. It's quite a simple aircraft. For students, you don't want to be too complicated. It has all the avionics that you need for student training, and of course we have our own avionics that we add to that, which is allows us to monitor the engine and the batteries, how the batteries behave. And all that data is super important because we recuperate that data, that's analyzed, and that's used for redesign, for testing, for justifications to the certification authorities. Actually, with this airplane that we're looking at right now, the design is exactly the same as its sister aircraft in combustion. And we didn't have to redesign the airplane to make it electric. In some projects, if you're retrofitting, there has sometimes adjustments be made. You may have to make the wings longer, but here you put two airplanes side by side, okay, and they look exactly the same. And as a matter of fact, a lot of the flight schools in Europe that have been buying the combustion version like the fact that it's exactly the same. So there's a seamless integration for the students, right? So they do their circuit flights on the electric, and then when they do their long distance flights where they have to go further, then if they get into the combustion, but it's the same airplane. So it looks exactly the same. The difference is if you open up, if we go in the inside, imagine, okay, I take out the wings, you'll see batteries and not a gas tank. In the nose, you'll also see batteries and a smaller engine because you don't need the big size of a combustion engine. So we use that space to add batteries. So it's a prototype, it's a test bed airplane. but it's flown quite a bit with lots of visitors, not just us. We've had all kinds of visitors from all around the world, pilots, CEOs, government people have been in this airplane. Yeah, we've had quite a few people. And whether it's this one or the second airplane, when everybody gets out of the airplane, they say, wow. And really experienced pilots, because there's no noise. You can take off your earphones and talk to one another. Of course, there's the sustainability side. It doesn't pollute, but it's very responsive, like an electric car. The pilots, so the feedback from the market on the performance is very, very good and very positive. H-55's mission is to make aviation clean, quiet, and efficient. So H-55 is what we call referred to as the technological spin-off or the technological legacy of Solar Impulse. A journalist friend asked me once, why do you think you succeeded? And the answer was brilliant, because we didn't know it was impossible and we didn't have any money. And when you think about it, where are the paradigm changes coming? I mean, the automobile industry was changed by Elon Musk, right? Apple changed the photography industry. The incumbents that I grew up with are no longer there, right? And, sometimes you need, someone from the outside to come in and, to think different, because you're not constrained, And what kept me in Solar Impulse was that entrepreneurial mentality, pushing the envelope, everybody working together in an organization, with one objective, is to build this airplane and show that you can go around the world. And it's great. When everybody's aligned with one objective, it's a fantastic environment, because you can have young social media managers working with experienced flight professionals and learning from each other. And the knowledge transfer within the company was phenomenal. Every day was like going to university, but wasn't sitting in a classroom. You were sitting in a real life environment. So that's what kept me. And then when Andre said to me, we want you to join, it took me a nanosecond to say yes. Well, when we started H-55, and again, we came from the Solar Impulse, we're the technological legacy of Solar Impulse, where we really, I think what we really understood well after flying 48,000 kilometers around the world was how to optimize the propulsion system. The propulsion system is one side, the motor, the drivetrain, the propeller. The other side, don't think of gas, think of batteries, and in between you have energy and power management. So it's a system that includes hardware and software, and of course we're very focused on certification. And we looked at the market and said, at the time in 2017, what does battery density, what can it deliver? And then we looked at, are there applications that would be relevant to this, to that? And then we quickly understood the flight trainer market, training pilots, was very interesting. The average age of those airplanes, the Cessnas, the Pipers, 35, 37 years old. So they're going through major, rehauls or changing their motors and large maintenance milestones that they have to, after a certain amount of hours that they have to undertake. Said, okay, this could be interesting, because a lot of the flight schools, training facilities, training centers were thinking about replacing airplanes. So that was good. We also noticed that, post-COVID, people were flying more. We needed to train more pilots. And flight schools being very sensitive to, particularly in Europe, to the noise, to the pollution aspects on one side, and then the economics. And that's where it gets really interesting, because in Europe, to fly an electric airplane is, the cost of ownership is much less than a combustion. Let me give you let me try an example. When you fill up your car, okay, and you spend €1, £1, $1, okay, you're actually getting 1/3 in propulsion. Okay, so 1/3 of that actually goes of that. You lose another third through the process of combustion, and then the other third, approximate numbers, go to powering other systems. With these airplanes, Solar Impulse was like 94% efficiency. This one is around the same thing. So you lose very, very little energy. So already, the cheapest energy you can acquire is the energy that you save, right? So we're starting to see the benefits. But again, sustainability, the environment is one part, and it's very important. The noise factor, particularly in Europe, where we have airports over densely populated areas, so that's an issue. But just the efficiency of it makes it interesting. And the fact that these new technologies, we're flying here, we're looking at a typical fixed-wing aircraft, but these technologies now are introducing new concepts in the market. We've heard of VTOLs, flying taxis, companies like Joby or Archer, and that's where these new technologies allow for different ways of flying. It's the same charging technology as automotive. Okay, that was a design, an important design decision. We didn't want to create a different system, a different set of hardware to make it more complicated. So, airports are starting to installing charging stations airside for their own vehicles. So we wanted to make it seamless in that. And basically, with this airplane that we saw before, that we took a tour, it's 1 hour of flying for 1 hour of charging. I think in the next couple of years we'll see some, it's hard to make predictions like that, but it's not unrealistic in 4 or 5 years to see, hybrids, and I think, in the commuter regional transport, okay, with fixed wings, with fixed wing designs, I think we'll see that, for sure in our lifetime, right? I think you need to look at what the aircraft needs to do, okay? And there won't be one-size-fits-all solutions. It would be very challenging to have batteries in a 747 or 757, from an airplane from New York to London. What we could do, and this is where we're talking to several companies in this way, is use the batteries for non-propulsion systems, okay? For everything else, so it's all about saving fuels. But for the EasyJets, the Ryanairs, the ones that we're using to bounce around Europe and flights for 1 hour, 1.5 hours, we see a strong potential in the hybrid. Okay, like with cars, but really, I use my Pratt. It might be challenging to have an EasyJet, an Airbus, 320 or 321 all batteries, but hybrid solutions, and a lot of companies are looking at that. So here's what I think of the role of AI, again, not being an engineer or an expert in the field. But, AI is a generic word and it's been used in so many. We've been using AI, for a long time in aviation, The systems, most flights, the pilots do very little flying. It's the computers that actually fly the airplane. You call that AI? For me, that's AI, right? But, so it's already been in the industry. I was driving to work yesterday. Even my cruise control in my car, is that AI because it knows that there's a car in front of me because it has a camera and it slows down automatically? I guess that's AI, right? I didn't make that decision. He made that decision, right? Based on the now, is he better at making that decision? Quicker making the decision? Probably. Okay, in some cases, not always, but yeah. So, those type of technologies, exist already, right? So I think the aviation industry. And let's face it, a lot what comes into the aviation industry comes from military first, right? And military brought us some fantastic technologies like GPS and things like that. So I think, and obviously aviation is a big component of the military. They financing, working with companies and, research and development. So there's a good momentum, especially in, countries like the United States. Again, looking at the world beneath us in a quiet way. Just the couple times I've flown, it's almost as if I want to talk to the pilot, but part of me just wants to take in the moment, and just enjoy the silence, because it's a type of silence that you don't experience every day. Okay, you have silence in your bedroom when you go to sleep at night, but it's not the thing. Imagine you're silent and you have this panoramic view. It's like you're watching like an old silent movie, except the scenery is not Charlie Chaplin dancing in a funny way. It's beautiful Swiss Alps with with gorgeous scenery. There's a whole experience side of flying. We've talked a lot about the economics, about the sustainability side about it, but there's the whole new experience of flying, and that's what really impresses people. So the future is now for me.
That was Gregory Blatt, sharing H55's vision of a future with greener and more efficient air travel. Now it's time to meet our expert, Mark Simpson from PTC. Hello, Mark. We've not spoken about PTC's Codebeamer before on Third Angle. Are you able to give a high-level overview of what it is and how H55 will be using it?
A lot of the industries that we serve are really focused on a shift in the market to software-defined products. And a lot of these industries, safety-critical industries, and then also there's a lot of rigor around regulatory standards that kind of govern and define these industries. So, our customers in these industries really have to equip their users with an ability to have extensive test management capabilities that test the product in a way that not only adhere to those standards and the safety requirements, but all of the regulatory requirements around those and produce very high quality products as well. So Codebeamer can achieve this with specifying requirements and then also mapping that back to testing or validating the requirement is actually implemented properly and with quality. It does that by tracing the requirement all the way across to the verification, and that ensures functional safety. Codebeamer is the product that does this. It's kind of a new generation of application lifecycle management, or ALM. And in addition to specifying requirements and tests, it also does risk analysis, and it also does that in a very agile way. In the industry, we call it SAFe, or Secure Agile Framework. And so simply put, Codebeamer accelerates software delivery while simplifying, regulatory compliance. So when we get to H55, this is a company that's just really committed to accelerating the adoption of clean aviation. And as part of that, and bringing these products to market, they have to have full traceability of the requirements that are specifying the architecture of the product, and at the same time adhering to regulatory standards and meeting the specific needs of each of their customers. So it's very flexible. So from the development specifications to their implementation of the products, it's really important to them that they're able to document and demonstrate conformity at every stage of the development of their product. And this is most important during the final or one of the final stages of testing and verification. And that way they can prove that their development is in line with their customers' expectation. And very importantly, that the standards issued by their regulators are also adhered to. So Codebeamer has enabled them to develop electric motors, and it also has provided a lightweight, scalable, and very high-performant platform for their product development.
Thanks to Mark and to Gregory and our producer Giles for taking us behind the scenes of H55. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and X for future episodes. Companies that make products the world relies on rely on PTC. This is an 1860 production for PTC. Executive producer is Jackie Cook. Location recording by Giles Blatt. Sound design and editing by Clarissa Maycock. And music by Rowan Bishop.